After learning about motion in 2 and 3 dimensions in Chapter 2, we now move on to an important section of physics, Newtonian mechanics. Of the 23 chapters of physics we cover in this tutorial website, Newtonian mechanics takes up approximately 1/3 of the entire material covered. Before we officially start with Hooke's law, let's first take a look at some of the basic concepts of forces. Okay, the first one is the 3 fundamental elements of forces. If you want to describe a force, you must include these 3 elements. The first one, the magnitude of the force. The second, the direction the force is pointing to. For example, a force exerted on an object pointing toward the north would be really different will have a very different effect than the force pointing toward the south. So in order to describe a force, you would also need to include the direction. Number 3, the object the force exerts on. Same reasoning as before. Exerting a force on object A will have a different result from exerting a force on object B. So in order to describe a force, we need to include 3 elements: the magnitude, the direction, and the object the force exerts on. As you can see, because force includes both magnitude and direction, force is in fact a vector quantity. In this chapter, we will be using vectors intensively, including adding vectors together, subtracting vectors, the dot product, and the cross product. If you're still unclear about these concepts, I would suggest you to pause the video right now and go to the math background section in the website for a quick tutorial on these topics. Okay, next we're going to talk about the effects forces can have on objects. The first one, forces can cause a change of shape. For example, you can stretch an object, by exerting a force on it, or you can compress it. The Hooke's law that we're going to talk about in later lectures is an example of forces causing the change of shapes. The second one is that you can change the state of motion the object is in. So change the state of motion. So you can change the state of motion the object is in. For example, force can cause the acceleration of a body. We'll talk about this in detail in Chapter 4. Okay, now let's look at number 3, the classification of forces. The simplest way we can declassify forces is probably by putting forces into 2 categories. The first one, action at a distance force. Distance force. For example, forces that act as a distance include gravitational force, electric force, and magnetic force. We'll discuss gravitational force in detail in Chapter 6. Okay, as long as the force we're talking about is not one of the 3 kinds of forces we mentioned above, then it is one of the contact forces. Contact forces include friction force, tension force, and spring force, and many other kinds. The main difference between the 2 is that for action at a distance force, no contact is needed for the force to be exerted on an object. So right here I'm going to write no contact is needed. Contact forces, on the other hand, require contacts. So require contacts. Let's say, for example, of the spring force. So we have a spring right here, in order to stretch or compress the spring, a force must be in contact with the spring, either that being your hands on the two sides of the spring or other equipments. Here we're also going to talk about another classification of forces. So classification 2. So the first kind would be gravity. Gravity is the first kind of forces. Second one, electromagnetic force. Magnetic force. Third one, the strong force. And the fourth one, the weak force. For the last two forces, the strong force and the weak force, they belong to the forces within an atom. In this tutorial website, we will solely focusing on the first two, gravity and electromagnetic force. Alright, next, we're going to talk about the unit of forces. So, unit of force. We know that a force can cause the acceleration of a body. Thus, it's reasonable to define the unit of force in terms of the acceleration that a force gives to an object. Let's say we have an object right here that has a mass of 1 kilogram. We then exert a force on the object so that the object has an acceleration of 1 meter per second square. We then declare that the force we're exerting on the standard body has a magnitude of 1 Newton. This N is just an abbreviation of the word Newton. Okay. Before we start the next lecture, I want to give you a reminder. So right here I'm going to write notes. And I'm going to talk about the difference between mass and weight. Well, mass and weight are two very different things. In our everyday lives, however, we often confuse the two things as the same thing. In later lectures, we will talk about Newton's second law of motion. And Newton's second law of motion says that F equals ma. In this equation, m is the mass. While when we're talking about a weight of an object, let's say a big W, is actually a force. So it's the magnitude of m times a gravitational acceleration g. G right here is called gravitational acceleration. Okay, let's write acceleration down here. Acceleration. Gravitational acceleration is just a kind of acceleration, so basically it's the same thing as a. Well, here's an important number that you should remember, and that's on Earth, the gravitational acceleration on Earth is, I'm going to write G equals 9.81 meter per second squared. This is an important number, and I wish you're going to memorize this. So mathematically speaking, mass equals to m, while the weight of an object equals to big W, as in force. So we have also, there's a hat over here, and hat over here to specify it's a vector. An example of this would be an astronaut on the moon. The person would have the same mass whether on Earth or on the moon. However, because the moon has a smaller gravitational acceleration, the astronaut would have a smaller weight on the moon. By just plugging in this equation, you can see that. Alright, in the next lecture, we'll talk about how to analyze forces.